Welcome to video 9. You can see here back in 05, 19th of the 2nd, 05, I started with an attempt to understand, to replicate Floyd Sweet's VTA. This came partly through frustration, partly through anger of knowing too well that history had been hijacked. Our history has been hijacked. We've been lied to, and to be honest, it's not getting any better anytime soon. There's been hundreds and hundreds and hundreds, if not even thousands and thousands, of machines that have produced excess energy. The volume of data is so overwhelming that for anyone that has done the research, done the proper research, it's evident that we've been lied to, that this information has been withheld. The human race, again, has been hijacked. Your history has been stolen from you. So I decided to try and do it as public as I possibly could, to get in and learn as much as I possibly could, as quickly as I possibly could, to try and get up to speed, knowing that some of these people that were showing experiments that were fantastic according to our super science that we had at the time, knowing that some of these people were highly educated. Some of these people had educations that not just a few weeks at, or even a few months at a course somewhere could sort of teach anyone. Mathematics wasn't my strong point. Electronics wasn't my strong point. Many things wasn't my strong point. I actually come out of a panel beating apprenticeship not too far before this, so I was fresh as a hands-on, dirty, sweaty panel beater. So I decided I'm going to do this for myself. I'm going to make an effort. I'm going to do it as public as I possibly could, and I'll learn as much as I possibly could, as quickly as I possibly could, to try and make a difference, to try and show people out there that yes, little things can make a difference. One person, if they have enough support from others, can make a difference. And it took me many years working mostly by myself. I had a few friends that, from sort of time to time would sort of join in and help out a little bit and stuff like that. But most of the time it was by myself. Most of the time I was doing all this, by myself on the bench. Little experiments here, little experiments there, and my life fortune was spent doing this. I sort of look back on it, and to be honest, I don't regret it. I think at the end of the day, I think the most amazing thing is what we've achieved over this time was actually the goal that was set out. Now, Floyd Sweet was a genius. Anybody that has at least the slightest little piece of research into Floyd Sweet will know that he was very highly trained. He knew a lot more than what most engineers, magnetic engineers, would know. Now, I've tried to validate some of his credentials that have been shown. I've not been able to validate them, which is probably quite obvious to most people. Depends on the reason, obviously, for the validation, but obviously at some stage he was trained somewhere. So I spent years and years and years trying to replicate Floyd Sweet's VTA, trying to understand the VTA, trying to understand Floyd Sweet, trying to understand the circles of people that he associated with, and so on and so forth. It took me a long time, and again I spent a lot of money doing this. And to be honest, I look back on it now, and just about all the money I spent was a waste. And when I say a waste because the money that I did spend didn't make a single bit of progress almost till the end. Now, when I was close to the end of this particular project, when I was close to the end, I had made some simple experiments that had proved that there were a lot of lies told. Floyd Sweet never conditioned magnets. For anyone that still believes that, honestly, you're in the wrong place. Floyd Sweet, he did play with the magnets because he was trying to learn about the magnets, but he never conditioned the magnets. The magnets themselves were never beaten around into any sort of shape. There was never any modulating magnetic field that was produced by the magnets themselves. There was never any of that. In fact, quite the opposite is true. And some of the experiments that I did, you can actually prove that the magnets had an extremely good, very high quality magnetic field in them. And I have proved in some of the experiments in these pages. So what I'm sort of trying to say, and the reason I sort of started with this in this video, is that people need to realize the absolute most simple things first. And I've tried to hammer it into people. I've tried to repeat it. It is a changing current will produce a voltage. An applied voltage will allow for a changing current. Electromagnetic induction is one way electrical energy can be created. Lenz's law does not mean that you cannot get more energy out than what you put in. Lenz's law is a utility that if Lenz's law is understood, first of all, and second of all, used properly, Lenz's law can be applied in such a fashion that it can actually be used to produce extra energy. Lenz's law is an assistive force if it is used right, and people have said that before in the past. I'm not the first person. So I think it's important. I think this is important. Now I look back on some of my old work and I think to myself, oh God, what an amateur. But that's great. I learned a lot. You know, there was a lot of experiment. There was a lot of learning. There was a lot of playing around. You can see there I scavenged a whole lot of capacitors out of the old ATX power supplies and sort of put them all together as a bit of a capacitor bank. Yeah, that was great. I learned a lot about capacitors and how by paralleling or series capacitors they made a difference to the overall voltage rating and also the capacity that they would allow for. So starting off, it was it was daunting. I sort of threw myself in the deep end, and I vowed that I'd never give up, even though I sort of from time to time I come close. I vowed that I'd never give up. I thought to myself, right, well, no one else is going to do this. We need to, if I want it done, I'm going to have to do it myself. And sure enough, how many years later? 30th of the 11th, 2014. So nearly 5 years ago now. It's actually nearly 5 years ago, almost to the day, but not quite. I come out and I was sort of showing coils that were opposing each other, the magnetic fields of each coil that would oppose each other. I had made some discoveries that did not lead me to the Floyd Sweet VTA, as the Floyd Sweet VTA is an offshoot, if you like, of this technology. This technology here is how Floyd Sweet got his VTA to work, and that is undoubtedly correct. but the VTA, there was a little bit more to it. So just to let you know that I finished this, or finished off the replication project, because I felt that there was no more that I could provide, and also I didn't want to go any further with what I had already learned, for quite a few reasons, and I don't really want to go into that, but anyway. So you can see here, if you were to go through and sort of read through, that I'd made sort of several discoveries, that you know, the right hand grip rule, for example, will give you a bit of an idea on where the magnetic field's going if you apply a current in a certain direction. I spent a lot of time learning about Lenz's law, electromagnetic induction, a whole bunch of different things. I tried to do it as cheaply as possible, but I think by the time I was about here, I think I'd spent about 200 grand, roughly. So it was a lot of money. Anyway, we sort of got to the point where, not long after this, I thought, right, well, it's probably time to make a bit more of an effort to get people involved, because right here, right at this date, I thought to myself, if it was just me, and if I just posted, you know, something pretty fantastic, and then all of a sudden I was to disappear, then all the work over the last, you know, 10 years would sort of be in vain. So I went to one of the forums, started sort of, you know, getting to know some of the people there, and sort of moving through the forum and trying to sort of share a little bit more. Most of the people sort of knew of my work, you know, from the website. Anyway, we sort of got to the point where at that stage we were studying some of the Cooler's work, a Cooler 0083. Is he Russian or Bulgarian? I can't remember now. I think he might have been Russian, but anyway. Anyway, some of his work was also very helpful in the work that I was doing at the same time, for the simple reason is some of it appeared to be, from the outside, along the same lines, along the same method, if you like. There were some things that he was talking about that I'd already talked about, and so on and so forth. I didn't know him. I'd not had any communications with him, at least not as far as I was aware. So I didn't know him at that stage, and I have never met him as far as I'm aware. So unless he's contacted me and been, you know, anonymous or something like that. So I had a pretty good sort of idea on what was going on. Some of these videos here, that one there, there's a lot of good information in there. But some of these, you know, updates do have a lot of good information. But it was about maybe about here that I think the path started to change. Actually, it might have been a bit before. And what I mean by that is I felt strongly that sharing the way that I was sharing wasn't a good way to go any further. I sort of thought to myself, we need to get more people involved. We need to get people doing this for themselves. We need to get people doing little experiments. You know, we need to get people thinking about what's it gonna take to get a voltage and a current out of the end of this coil. And really, at the end of the day, there's three things that you need, and that's all you need to light a small light. Is you need a coil, you need a magnet, and you need to move either the magnet or the coil. That's the three things you need. It's all you need. And the simple thing is, basically, you all you really need to think about is a changing current produces a voltage, and an applied voltage will allow for a current to change. So that's electromagnetic induction, and it really is as simple as that. Now, energy, really, it's already there. It's already in the coil. It's all the charge that's in the coil. It's every electron, it's every ion or hole, if you like. Any charge that's in the coil, the copper coil. And remember the very definition of the term conductor, so that the conductor will carry a current. the very definition of the term conductor means that charge can flow through it. So we need to sort of break this all down to the absolute most smallest, simplest, logical pieces of information and start applying it much more simple. It's been way overcomplicated. Some of it is complicated, but some of it's been way overcomplicated, and we've been lied to for too long. I mean, realistically, for $20 and an hour's work, if the person on the bench knew what they were doing, they could build themselves a small energy machine. I mean, Coil did it. He's shown hundreds of videos. You know, a small machine, probably under $20. I mean, he salvaged a lot of his parts. Probably didn't even cost him $20. You know, an hour's work, and here he was showing, you know, people running energy machines. It would be lighting LEDs, you know, continuously, sometimes for hours at a time. There's no way that a capacitor, you know, of 10, 100 UF could light, you know, some of these LEDs as long as they could. There was energy coming from somewhere, and the energy was being pumped. Okay, the energy that was powering the load was being pumped out of the coil, and to pump energy, you've got to put it under pressure. It's as simple as that. It honestly is. So a pressure is two opposing magnetic fields. Again, simple. It's a pressure. It's a pump. Any pump must create a difference in pressure. So to pump anything, whether it be liquid or anything like that, you've got to have a difference in pressure from one point to another. And to pump, you've got to put the pressure in behind what you're pumping, whether it be liquid or whatever, to pump it to where you want it to go. And that pump is electromagnetic fields, two of them opposing. They have to be two opposing, and the two that are opposing cannot be your input. And that's how, it's as simple as that. That's how you get rid of the whole problem of conservation of energy. Conservation of energy is only viable, only true, and you know, I mean, this has been pointed out quite a few times in the past. It's only true in a closed system where the system will not allow an extra source of energy to come into the system. Now, all you need for a source of energy, as we said before, is a changing magnetic field in the proximity of a conductor. So when a conductor sees a change in magnetic field, a steady static magnetic field does nothing, but a change in magnetic field, which is a change in current, by the way, then you see a change in voltage. So pretty much the pump can be set up so that the magnetic fields, once they're brought under a certain condition, the magnetic fields, because we have three of them, and remember that 3 is not symmetrical, you can't get symmetrical out of 3 if you have two output coils opposing, two output coils, and those two output coils are opposing each other, then one of those output coils must assist the primary. There's no other way it can work. It's an asymmetrical system. So it's really simple. It's so straightforward that it's just not funny once it's been broken down to the smallest possible pieces. What I mean by pieces is, if you were to look at the Tom, Beard and Meg, along with the other guys as well, Steve Kenny and all them, if you were to take the Meg itself, even just the name, motionless, implying that there's no rotation of a rotor. Okay, so motionless, implying no rotation. Okay, so if we have a generator, the generator must have a shaft, and the generator must have a rotor, and must have a stator. Okay, so typically you would think of the shaft turning the rotor having magnets on it, the magnetic field actually cutting the coils, the coils then producing a voltage. A changing magnetic field produces a voltage. So electromagnetic generator. So motionless electromagnetic generator. So what they're implying here, just by the very name itself, implies that the magnetic flux in the core is being made to move to cut the coils to produce energy. So it's a motionless electromagnetic generator. There's no shaft and there's no rotor. This is just the stator. So it's implying just in the name alone that the processes here being described are still exactly the same as a generator. They've just figured out a way to have no rotor, no stator. The magnetic fields are the interactions of the magnetic fields in the machine itself. Any machine with at least two magnetic fields, 2 is the minimum, 2 is normally symmetrical. So if, let's say for example, which is not true, but let's say that this coil over here was our primary coil and we were to drive our primary coil over here, creating a magnetic field over here. This coil over here would be a secondary coil. This would be the load. That would be inductive, obviously, visually to this coil over here. As the current changes in this coil here, the voltage over here would change, and because it's loaded, then a current would flow. Then this coil over here is electromagnetically inductive compared to this coil over here. So electromagnetic induction, it is exactly the same in a generator and a transformer. There is no difference. It's the same process, it's just a different way of doing it. So the changing flux of this coil over here, which could be represented as the shaft turning the rotor with the magnets on it. That's all it's representing. Now we know that this coil over here and this coil over here are independent input coils, and these coils over here, this one here and this one here, are output coils. We know that. We already know from all our research. So what we've managed to do is we've managed to take the mag, remove the shaft, remove the rotor, and still generate electromagnetic energy. It's an electromagnetic generator and it's motionless. Now this is something I just wanted to show everyone. This is something that's been up for a while. So one build-up produced 100 times more power out than was input. Okay, so it's not hard, it's just the way that people think about it. People need to erase the lies that they've been told. People need to erase the falsities. People need to start thinking for themselves, thinking outside the box, saying, I am only going to let myself be limited by what I choose, not by what someone else says. Okay, I mean this is just one of hundreds and hundreds and hundreds of devices throughout history. I mean, Lester Hendershot, you know, T. Henry Moray, you know, I mean the list goes on and on and on. Got to think outside the box. You got to think changing magnetic field. You got to think, you know, load. You got to think, well, you know, what's going to happen if it's symmetrical? What's going to happen if it's asymmetrical? We've already shown all of this. You know, video 6, a symmetrical machine. Video 7, we went asymmetrical, and look what happened. Almost instantly, without doing any real work. It was only a few minutes on the bench, and we got a successful result. And what's more, the result was in line with what Andrei Malenchenko told us some 10 years before, or even more. It was about 2004 or something like that. And also, which Tariel Capanesi has also said in some of his early interviews. So we've got to think outside the box. Don't let yourself be limited by something that someone out there that we don't even know who it was threw their hands up in the air and said, "No, can't be done. Can't be done. Absolutely, 100% can't be done." And that's it. This is the law. Okay, well, I'm here to tell you it can be done. I'm here to tell you that we've shown experiments that give you not just a foot in the door, give you pretty much the exact way to do it. I'm here to tell you that there's other machines that work on the same principles. I'm here to tell you that those other machines have also shown the same results, if not similar to very, very much the same. It's not rocket science. Okay, you got to think simple. You got to break it down. You got to make it simple. And that's sort of where I was at. I sort of made these early discoveries over here. Through some of this opposing magnetic fields. Look, this over here is opposing one way. This is opposing the other way. Over in this post over here, we talked about some of the Russian parametric oscillators and all that sort of thing. I learned a lot when we were doing that. Over here, like measuring the weight of a mock-up VTA with the same sort of turns and stuff like that. That was pretty interesting to find. We also checked things like shim stocks or razor blades. There's a lot you can prove just by replicating something, and even if it doesn't work, there's still a lot you can prove. So anyway, I mean, even down here I was investigating opposing magnetic fields. There's a ton. I think I got a bit sidetracked over here for a little while, some of the Viali stuff, and that's why I warn people as well, by the way. I warn people, don't get sidetracked, don't listen to what people on the forums will tell you, because that's why they tell you. Sometimes some of the stuff is complete rubbish. Not Richard Viali. Some of his stuff did work, but it sidetracks you, and that's the reason they do it. So they try and get you sidetracked so that you lose momentum in what you're doing. When you do something, you've got to stick with it and you've got to get it going. I mean, over here we knew that there were some lies told. The magnet conditioning process described by Tom Bearden was not true, but I don't know how Tom Bearden got that story. I don't believe off the top of my head that Tom Bearden made that story up. I believe that Floyd Sweeten may have told Tom Bearden that story and gave him information to try and throw him a little bit off track. But I have a funny feeling that Tom Bearden may have known that magnet conditioning was false. So I've done a few projects. Some of the ferroresonance, they talked about ferroresonance with a cooler and stuff like that around the 2014 mark. Floyd Sweet was about 2005. HHO about 2007. The Meg was about 2009. So there's some pretty cool stuff there. Some of my research, a free energy device, that's Paul Raymond Jensen. There's tons of stuff on my website. Go and have a bit of a read if you want to. Hydraulic ram pump. Funnily enough, when I was a kid, I don't know, maybe 11 or something like that, or even earlier, perhaps about 7. My dad and I, we sort of mucked around a little bit with the hydraulic ram pump, and I thought that was fantastic. I just couldn't believe that something was sitting there, and the energy was coming from the gravitational force on the water flowing downhill, and this machine was running from essentially from nothing. There was nothing plugged in. It was the energy of the water that was making this machine run, and it was a resonant machine. It basically ran at a frequency that was resonant to the way the system was built. You could get it to run faster or slower depending on different things that you did to the machine to change it. So that was a fantastic little exercise. I was very lucky in my life, I guess, to actually experiment with those things at such a young age. Perhaps a great deal of influence on me. Lenslaw, Lester Hendershot. I really like Lester Hendershot. I think he was a giant. He never stood a chance, even though he had connections in some of the highest places that I've researched. I mean, effectively, he was building machines for the U.S. military back in the 20s. Now, I'm sorry to say, but a man building machines for the US military back in the 20s, and we still haven't got these machines out in public. Anyone with half a brain in their head can see straight through that and say, yeah, we've been lied to. Yep. Magnetic modulation of charged particles. This is what we are doing, my friends. We are modulating the charged particles inside the copper wire with magnetic fields. We're modulating, putting them under pressure, we're pumping them. Remember Floyd Sweet, the original name for the Floyd Sweet generator was the space quanta modulator. Nonlinear inductance, this is some of the Andrei Malenchenko stuff. I didn't actually click to that until a little bit after I'd actually already put all this up, so I'm not even sure if I've even given him credit on some of that stuff. I do apologize, I should have. Some of the Borderlands, the early Borderlands stuff, I mean, that was done pretty early. It was 2013, but I'm pretty sure that was an experiment that I'd put up at that stage that I'd done a lot earlier on, so I'd sort of shared the information from a lot earlier. Anyway, look, I don't want to sort of bring the history up too much, but I think people need to know the history for the very simple reason is otherwise they're going to repeat my history, and I don't want people to repeat my history. What I want is I want people to learn from my history if that's what they choose. I want people to save their money if that's what they choose. I want people to experiment and replicate what I've shared if that's what they choose. I want humanity to catch up the 100 years plus that we've lost. That's what I want. I want humanity to be what humanity is supposed to be, like JFK said, free and independent. It really makes me mad that so many people have been oppressed for so long. We are effectively slaves we're a slave race, and I don't know who to, but we are slaves. We've been lied to. It's just not fair. Enough's enough. It's time for people to either do this for themselves or be happy continuing on being a slave, and I'm not. I want things to change. So this is why I put so much effort in. This is why I try and encourage people to do what they what they want to do. We don't get a lot of views on our videos. I wish we got more views. I wish we got more interest. I wish we saw more replications on our website. Come and visit us. Be part of something better. Our website it's unique. This is one of the most unique websites you're ever going to find on the internet. There's no one else out there like us. We've shared more information. We've given more information to humanity than any other website out there on the internet about what we are doing, about helping people to become free and independent. If that's what you want, then this is the stand that we all need to make together. Okay? It can't be done, well, not by one person. It's got to be done by everybody. Again, light up the darkness, because that's what we need to do. The darkness is shrouding humanity. We need to light it up. Education is the path forward. So look, please come join our experiments. Chris's non-inductive coil experiment is where you'll find this series of videos specifically. We've gone through lots and lots and lots of different experiments. There's lots of threads on the forum that are very important, but this is where this particular series of videos is located. If you have any questions, please ask. We've got a lot of very knowledgeable members fantastic bunch of people, so I want to put a big shout out thanks to them. Come join us, and try and let's all move forward together on this, because it is so important. If you have kids, you'll understand that you don't want your kids to live as a slave. We don't want our future, we don't want our kids, our grandkids, their grandkids, to live as slaves. It's time we broke the chains and moved on. It's time we become the race that we are supposed to be. It's time to stand up, stand tall, and not let ourselves be oppressed anymore. Okay, so just to reiterate just a little bit, this is some of the progress from video 7. Again, we have our asymmetrical transformer. Okay, this is our DC pulsed input in the background. That MOSFET there is switching at 3 kilohertz with a 10% duty cycle, 10% on, 90% off. Okay, so this coil over here, 1, this coil over here, 2, this coil down here, 3. Okay, the top coil and this bottom coil down here oppose each other. Okay, we have a magnetic interaction between the two coils. The diodes here separate these interactions between the coils. Okay, so when the input is turned on, okay, our 10% duty cycle starts these two coils in a bit of a fight for each other. The fight, if we time it right, and if we get it into the optimum point, this fight here is resonant. So the magnetic field from this coil and the magnetic field from the bottom coil down here are exactly equal and exactly opposite at the same time, and our input effectively sees no load. Alright, that is the secret. Our input will effectively see no load. And in fact, to be perfectly honest, sometimes power can come back through your input to actually charge or try and power the source. Okay, so be aware of that, because it can happen and does happen in some situations. Okay, so when these two coils here are in a resonant situation, this coil here opposes the bottom coil over here, and if it's in a situation where it's equal and opposite at the same time, the exact same magnetic fields, the exact same everything, then the magnetic field interactions between these coils is only excited by the input over here. Just remembering, it's the change in current that produces the voltage. Okay. Alright, now I just want to be perfectly clear at this stage. What I'm showing here is just the start. This is one small experiment in a much bigger scheme. Alright, so please understand that what I'm showing here is one small experiment in a much bigger scheme. This can be done lots of different ways. What you're seeing here is not the only way. Okay, it's just the start. It's giving you something to aim for. It's giving you a machine that you can look for the effects for. It's giving you a foot in the door where no foot in the door existed before. Alright, so just remember that, because it is important. Okay, so again, just a close-up. Okay, you've got to remember the asymmetrical transformer. That's the critical part. And when I say asymmetrical, people might say, oh, what do you mean? What do you mean? Well, asymmetrical means where you don't have one magnetic field being the input completely opposed by the secondary, which would be the output. Okay, that's symmetrical. What you have is you have an input that's not opposed directly, at least anyway, by your output. Okay, so it's asymmetrical. What you're using 3 magnetic fields to counterbalance each other. So the equation would be 1 plus -1 plus 1 equals 1. Whereas for a symmetrical transformer, it would be 1 plus -1 equals 0. So you're left with nothing excess. There's no excess at the end of the day. And when I'm saying 1 is the magnetic field. 1 is one is the magnetic field from each coil. So the primary coil here will be 1. Okay, the secondary coil up here might be -1, which is back the opposite way, and then the tertiary coil, which may be, again, this is completely up to you how you define the coils, but you sort of get the idea. The tertiary coil would be +1 again, so +1 would assist the primary. Okay, so it's in a forward direction with the primary, and the secondary would oppose the primary. So if you have one opposing the primary and one assisting the primary, then 1 plus -1 cancels out, so there's no load on the primary. Alright, just a close-up of the diodes. Again, the measurement resistors, these are just metal strip through-hole 0.1 ohm resistors, good old O1 oscilloscope. Okay, another bit of a close-up. Alright, just a few messy, horrible scope shots. Now the numbers, I'm not going to debate the numbers. You can see some of the numbers here and you can get a bit of an idea, but really what I'm trying to show is I'm trying to show the asymmetrical regauging. Alright, asymmetrical regauging is really important. I hope this sort of makes a bit more sense. Tom Bearden's shown it for a long time now. We've seen it in many other devices. It's a pretty critical aspect to get these machines to work. If you don't have the asymmetrical regauge period, then you can't have the work period that follows. So asymmetrical regauging means that we've got, say for example, 10% on time and then 90% off time. So that means that the machine is doing work 90% of the time, okay, and the input is only on 10% of the time. The input is the time when the machine is regauged, and that's when the coils are brought back up to potential again. Okay, this is the regauge period, so we can see here. I've got to apologize just quickly because in the video I actually marked from here to here as the regauge period, but it's actually from here. So that there is 10% in the overall duty cycle. You can see there's a fair bit of ringing and stuff going on in here, but that's normal. That's just how it works. It's part of the whole thing. Now the ringing can be used so that you hear and understand what I'm trying to say here. The ringing can be used to actually find frequency that could be more advantageous. Okay, so look at the ringing and think about what the ringing is doing. Okay, just another close-up. Again, the 10% on time you can see between the spikes. So from this one here to this one here, it's 10% on, and then the rest from here to over to here is 90% off. Okay, so from on here we've brought our coils up to potential. Okay, and then we're letting our coils drop down the potential. Okay, so off time over here, the machine, when the input is off, the machine still outputs energy to the load. Alright, it outputs energy to the load in between here and here as well. So for 10% on time, we're still getting energy out to the load, but again, because the partnered output coils oppose each other, there should be minimal load on the primary coil. You've got to think about that. It's something that I've had a few questions before in the past. Some people said, "Oh, well, you've always got the primary being opposed." Well, the primary is only being opposed if it's symmetry. If you have, say for example, if you had Iron Man and what was his name again, Iron Patriot, and they're both, aiming their hand pieces, their hand weapons towards each other, yeah, and then at the end of the day there's going to be a great big huge opposition, isn't there? And we've seen this before, and I'll just show that. Hang on just a sec. Alright, so here you go here. Remember, I am the original EM junkie. This was a response to Maglovin, and down here it is, Iron Man, Iron Patriot. Okay, what we're doing is we're aiming two different forces of equal magnitude but opposite direction toward each other. So I mean, this is a pretty scientific sort of thing. If you study this, you will see it throughout nature everywhere. The sources themselves, here and here, if you aim something at the middle, it will tend to collect in the middle, at least to a certain degree. There might be reverberations or something, which you do see later on, or I should say shock waves. Anyway, the point of this is look at the actions and the interactions. Okay, if you were to sort of go through and have your 10% opposition from here to here, and you have two coils oppose each other, two secondary coils oppose each other, then the net force on the primary will be very low to even zero. It depends on the coupling of the coils. If you adjust the coupling of the coils, you might be able to change the situation. So you've got to think about a few things, to make sure that happens that way. Okay, again, this is the bit with the light. Okay, so this is the load on the second coil. Okay, so again, 10% on time in here. Okay, we've brought our potential down to zero. Up here, a potential still up at channel 1, red channel, 200 millivolts per division, so we're nearly 400 millivolts just here, and that's current. Okay, so we're 400 millivolts just to the load, just on that coil. So I think it's pretty important to sort of say, we're getting the same, decay over time here. We've got an on time here where obviously the on time is, we're seeing it. We can see the effect of the on time on one coil being slightly different from the other coil. Okay, we saw perhaps a little bit more of a ramp up on the other coil, whereas this one here, we're seeing it being brought down much quicker. So these are the little things that you might need to sort of just keep an eye on. Just again, this is a successful experiment. It's just that it could be done a lot better. A little bit more of a look in at the switch in. Okay, this is again, we're seeing a pretty sharp, steep drop off here. Just a bit of a different shot. Okay, a little bit more information on the other traces. And again, this is the output current. No, sorry, it's not. This is the output voltage is yellow, and output current, the red. So yeah, the total output here, 700 milliamperes. And because the voltage spikes were too high, we weren't getting a very good mean reading, so it was 17.57 volts on average. So again, this is just a rough scope shot of what was going on. Changed just a little bit there. Just so that you know as well, I don't always, but I try to have a look at the mean and have a look at the cyclic RMS. Sometimes you'll see a huge difference, sometimes you'll see a very small difference. If you're wondering what that is, we've done a couple of videos on it and done on a few threads on our website, on the aboveunity.com website. So jump in, have a bit of a look. Cyclic RMS, you will measure the energy going forward and the energy coming back. Okay, mean is normally the mean energy that is traveling in one direction. Okay, so mean doesn't give you a net energy moving one way plus the energy moving the other way. Mean will give you the net either moving forward, the gross, or the gross energy moving forward as a total, or the gross energy moving back as a total. And if it's moving back, it'll come through as a negative, so it'll be negative 703. But it's not, it's moving forward, so it's a positive gross current of 703 moving forward. remembering this circuit, the current itself actually had a diode in there, so I'm not sure, to be honest, I'm not sure why there's so much. Maybe it's because there's information that's off the scope. Anyway, alright, so I think that's probably enough of that. That sort of goes through, that's video 7. If you were to have a look at video 7 again, there's some pretty good results in there, considering 12 volts input was just over 400 milliamperes, I believe, was the input. Again, I'm not going to debate numbers, it's not what I'm here for. You either take this and start doing a little bit of research on it, or you don't. Really, at the end of the day, it doesn't worry me. For those people that do want to do it, I'm more than happy to help. For those people that don't want to do it, I'm not twisting your arm, and I've got no intention to. Okay, so this is either can be used or not used. It's up to you. I'm not here to debate numbers. I'm not here to debate how it works. I'm not here to debate anything like that. I just want to help people. So, for everybody out there, I think this is probably long enough. We've got a 40-minute video or something. For everybody out there, if this video has helped you, I'd like to ask if you can afford a small donation. That would be awesome. It takes a lot of time to get these videos together. It takes a lot of time to show everybody the work that I've been doing. I'd very much appreciate it. So great big thank you to everybody. Come visit us, be part of something better.